Great. This is the second video in a series to try and help you get set up creating a database and then interacting with the database with your code. So the first one, we created a user interface where you could type in a username and a password with a login button. We had a debug box so we could just display some messages quickly. And we set up a table in a database using SQL Server Express, but you could quite happily use anything that you liked, like SQLite or something like that. We made a users database. So we typed in some SQL to create it, or we could have used the designer view. Let's create a new table. So this time I'll use the designer, and then this table name, I don't actually know how to change the name in the designer, so I'm just going to put it in here. Let's create a notes so that we can see a note associated with a user. So we need an ID, which is going to be the ID for the particular note. That should be the primary key. Let's make a user ID. So that's going to be a foreign key. It's just an int. Don't want to allow null. And we should also have the actual note itself so that we can keep track. So we're going to want some text in here. So they're just a text. I suppose we could do varchar max, or yeah, there we go, text. So I don't know how much that is. That depends on the database. It could be 64 kilobytes. It could be megabytes. It depends on how the database is set up. And yes, I will allow null for this one. So if we were doing this properly, we would set up the foreign key relationship in here. So how do we do that? Well, the foreign key in this table is the user ID. So we want to say this is a foreign, I can spell foreign, right? Foreign key, which references, now this is way beyond what you need to know for the exam, but it's quite useful for your code. So which table does it reference? It references the users table. Which fields does it reference within the users table? It's the ID. So there we go. Hopefully that'll work. We need to run the script, which will execute this transaction. And remember, a transaction means the whole thing succeeds or the whole thing fails. Great. And there's also a generate script button, which is really helpful. It will generate some code for you to be able to do that. So hopefully now if we refresh, we've got two tables. Here we go. So let's add in some data. So I don't want to go to the design view this time. I want to go to the table data view so that we can see the users. Let's have a user ID of 1. Let's have my username. And I don't know what the password hash is going to be. I'll just put that in for now. And let's have another user who's going to be a guest. And the password hash, I'll have to generate this later. I'll pop that in later. Okay, so let's see, we've got me with an ID of 1. So if we put a note in, so that's the design view, I want to go to the table data. Sorry about the drilling in the background, they're fixing the staff toilets. So we can say the user ID is going to be 1 for me. I like chocolate. There we go, that's my super secret note for you. And that should be saved in the database now. Remember, this file will not work if it's on a shared network path. It needs to be on a local, preferably on the C drive or something like that, because only one process is going to be able to access it at a time. We need a lock file to ensure consistency and isolation in your database transactions. Right, so now we want to actually connect your code to it. So let's have a look and see how we can do that. So when I press login, I would like to be able to query that database and see if there is someone with that username. So I've done a quick Google to try and find out how to do it. Remember, if you ever use a website, then you need to keep track of where you get your code from. So let's say based on or adapted from. And let's see if we can work out what to do. So it looks like we need a connection string to our file. Then we need to have our SQL statement. Then we have some code to be able to interact with it. And let's see what that looks like. So how do we get the connection string? Well, if we click on our database, there should be a connection string in here that we can copy. So that looks promising. So let's set that up as a string. String connection string equals. Probably going to use this multiple times in the project. So let's make it full screen so we can see what's going on, and cut it to make it more like a global variable accessible to any part of the program. All right, what's next? Then we want to initialize a connection, an SQL connection, using our connection string. So we need the SQL connection C or connection, and then equals new SQL connection. Okay. Using our connection string, and it will probably not know where that is. So Alt and Enter, and we're going to use system.data.sql client. That looks good to me. So we'll attempt to make the connection. And then we've got this using statement here. What that means is that you get a scope for that variable, as in you get the mustache brackets, the curly braces that say anything between here and here uses this variable, and then afterwards it will free up the resources and look after the memory management issues, close the connection all for us. So we need a SQL command. So SQL command cmd equals a new SQL command. And with our SQL command, what do we need? Well, we can have one with nothing. We can have just the SQL statement, or one that has a connection. And I think that's what we're going to need. So let's have one that has an SQL string with our connection. That means we're going to need to specify what our SQL is. So string SQL equals. Okay, so what SQL do we want? We want to be able to look up someone that has a particular username and a particular password. Now, I'm not going to do authentication at the moment because I put in dodgy password hashes and I don't think that will work. So I'm just going to look up somebody by username. How do we do that? Well, in SQL, we'll do select star from. That means select all of the fields from the users table where the username is equal to something. So we'll do it in a unsafe way first. So username is a variable that we've got. Let's put that in so that we can access the variable value. And then hopefully we can execute that command. Let's see. We'll come back and deal with the parameters a little bit later once we've explained why that's necessary. This is executing a non-query. Well, we want to actually execute a query so that we can get results back. So let's see if we can do that. CMD, that's the command that goes through the connection to the database. Let's execute a reader so that we can get the results back. And what do we get back? We get an SQL data reader. SQL data reader response equals. And then what do we get from response? Let's have a look. Dot read. Okay, so this has this just returns Boolean, which presumably means have we got anything there at all? So we can do whilst we've got something to read, then we should be able to see that we've found something. We found a user. Okay, I'll put the log thing in first so we can see we're attempting to log in. Then maybe I'll also log the SQL statement. Oops, I'm in American keyboard layout. Come on. That's better, sorry, Control and Shift toggles back in. Executing SQL, and then let's display that here. Fab. And then I want to be able to view the results here, but I'll just put that in as a to-do thing and see if it works. Right, so hopefully our program will be able to connect to the database, we shall see. What have we got wrong here? It's because in the connection string we have backslashes, which we need to escape, or we need to say this is a string literal, so we don't need to escape those. But if there are any quotation marks in there, which there aren't, that would be an issue. So that's fine. If there were quotation marks in there, we just have to put double quotation marks in. But the @ sign in here means that we don't have to escape all the special characters. Let's try and see. Apologies if it takes a little bit of time to load. It's looking promising, but will it load the form? Here we go. So I'm pressing login, and we have an exception here. The execute reader requires an open and available connection. So we have a connection, but I just have forgotten to open that connection, which seems a bit silly to me. But let's try it. Connection.open. We don't need to remember to close it because we're inside a using block, and once we're outside of this scope, it will automatically close it for us. Let's try again. So what is the connection? The connection means that our C# program is connecting to that MDF, that access database. So no exception this time. Here we go. Attempting to log in with something and something, which means it's executing the SQL, the structured query language. Select everything from the users table where the username is that, and then presumably it's getting something, but our program doesn't know what to do with it yet. Let's see. Okay, so response dot. So we should be able to get whatever we want now from our database. Well, let's see. If we're getting a user, the user's database has. Let's bring up the. Oh, come on. We have a username and we have a password hash. So let's show both of these, shall we? Let's get the username and the password, and both of these are varchars. They're just strings, essentially. So response.getString. This, presumably, we need to say which field we're after. So the first one is going to be ID, and then username, and then password hash, or whichever order we specify in here. So if I only want to get the ID and the username and keep the password secret, then, and we only want to display the username, then that would be 0, that would be 1. Let's get the value, the field at position 1. Okay, so let's log this. Found a user. Username is this, and ID is okay, and then let's pre-process that string. Oops, what on earth did I press then? Don't know. Sorry. There we go. Make it full screen so you can see a bit more what's going on. Fab. So if we manage to find something, it should display the response from our SQL data reader. The first field is going to be the ID. The second field is going to be the username. Hopefully. We'll see if it works. And then we want to actually implement the authentication. So we'll see. Let's search for somebody with no username, and it hasn't displayed anything there. But what happens if I put in string p? Okay, unable to cast from int32 to string. Why? Because int32 would be the ID, and I've said to try and get the string. That was silly, wasn't it? So get, is there a get int? Yeah, int32. Let's try again. At least it found something. So it can't find it if I just go string. But if I go string p, then we found a username. The username is string p and the ID is 1. So I said this was a bad way of doing things because you're injecting things directly into the SQL statement. For example, you could put a malicious string in here. You could say find anything. So select the ID and the username from users where the username is. Well, if I put a single quote in there and I say or 1 equals 1 and then put a semicolon to end the SQL statement and then a comment so that the rest of the SQL statement is ignored, and I run this, then we've got an error in here somewhere due to the SQL statement. What does the SQL statement look like? Probably I've done the comment wrong. Yeah, I think I put a comment in wrong. So let's have a look. This time we'll say a single quote to end the search string. We'll say or 1 equals 1, so that regardless of what username we're searching for, we'll always match everything. End the SQL query and put a comment in with a double dash. Hopefully that'll be better. And see if this works. Yeah, here we go. So this is an SQL injection here. This is what we're actually searching for. We want to be able to search for a user with that username, but what's actually being executed is where the username is that, or 1 is 1, which happens all the time, and ignore the rest of the query, and it's found all of the users. We've just exposed everybody's user details to the user. So that's a problem. How do we fix the problem is more important. So let's go back to the web page on here that had a good example of parameterized queries. And let's see what we can do. Okay, so notice here, it doesn't put the actual values into the SQL statement. It uses at and then the name of something. So that's what we're going to do here instead. This is liable to be exploited with an SQL injection. This is going to be automatically filtered. So if we say the username is going to be the username, then this will be loads better. But we need to make sure we add in some parameters to the SQL command. So how do we do that? SQL command.parameters.add. And what do they do here? Let's just do add with a value, I think would be better. And then we can say the name and the value all in one go. It's just a little bit more concise than what's been done here. Okay, Control-Shift-Space to bring up the IntelliSense hint thingamabob. So the parameter name is username. And then the value that we want to search for is what the user has typed in the box. So we've got a variable called username. Let's plop that in there. All right, let's try it and see if it works and see if it's still vulnerable to an SQL injection. First of all, we've got nothing. We found nothing. We've got something. We expect to find something. Yes, we do. This time, we'll try an SQL injection or 1 equals 1. End the transaction, end the statement, the SQL statement, put in a comment to ignore the rest. And it executes it, but look, it's not putting that directly in, injecting it in a vulnerable way. It's correctly filtering it so that we don't get any malicious results. Much better. So now, I think I'm going to pause this video at this point, and I'll make another one so that we can do actual authentication, so that if you log in correctly, it will then let you go through to another form.